Hi, grade 12. Today we are doing the May-June 2023 question paper, and I'll be starting with question 8 under the section of geometry. So question 8 says, in the diagram, O is the center of the circle, KT and L are points on the circle, and ST is a tangent. And it says STK is 36 degrees, and angle OKL is 18 degrees. So the question says, 8.1.1 for number A, calculate the size of angle T2. So because we have this radius and this tangent, we must remember this theorem that says if I have a tangent and a radius that meets, then this angle here, this whole angle between the tangent and the radius is 90. The first question is, what is the size of angle T2? So angle T2 is this angle over here. And if you have a radius and a tangent, this whole angle is 90 degrees. So T1 plus T2 is 90 degrees. And the reason is tangent is perpendicular to radius. If T1 is 36, then T2 is 90 minus 36. So T2 gives me 54 degrees. And then I go to my diagram and I make T2 54. Our next question is question B, and they want the size of angle L over there. So when I look at angle L, I'm going to move back to T, and I'm going to see where this one can go. This one can go back to K. So that's a chord. The chord is called KT. If I make a little triangle like this, you see the triangle? There's the tangent. That's the angle between the tangent and the chord is equal to this angle in the opposite segment. If I had to take that out, I would show you it's like that. There's the triangle. So this angle is equal to this angle. I'm going to write number B. I'm just going to say L is then just also 36. And the reason is tan chord theorem. Okay, so let's remember to put in our 36 here. So this is 36 degrees. So the next question, question C says, calculate the size of angle KOT. So KOT is this angle over here. That's the angle at the center. So I'm going to go down from the center. Let's see if I can find angle at center twice angle at circumference. So I go down and I hit the chord. So the chord is KT. So I'm going to move from K and T and see if I can go to the circumference. So from T, I can go to L. And from K, I can also go to L. So there I have angle at center twice angle at circumference. So the angle at the center is the bigger one. Number C, angle KOT is double 36. So it's 2 times 36, which is 72. And our reason is angle at center twice angle at circumference. So now remember, I'm going to put in here, this is 72. The last question by question 8 says, prove that Km is equal to ML. So there's this theorem. It says, if you have a line coming from the center and it is perpendicular to a chord, if that is 90, it means this is equal to that. So if we can prove that this angle is 90, then this is equal to that. Now in triangle O, M, and K. So I'm going to take that triangle out just to show you. we worked out this is 72. It was given that this is 18. Can't we work out the size of angle M? So angle OMK is equal to 180 minus 72 minus 18. My reason is angles in a triangle. So angle OMK is actually 90. And there we proved it. It's 90. So this angle is 90. And if it's 90, the line KM is definitely equal to the line ML. Why? Because line from center is perpendicular to chord. Okay, grade 12s, let's look at the next question. It says 8.2. In the diagram, triangle RDS is drawn. A, B, and C are points on RD, RS, and DS respectively. Okay, AB is parallel to DS, that's important. And RB is to BS, 5 is to 3. Okay, let's put that information in. RB, so RB is this line, this is 5. And BS is 3, but because that's a ratio, let's add a letter. So I'm going to add K to show that that is a ratio. It also says that DC is 20 units and CS is 12 units. That is already on the diagram. And the question is 8.2.1, prove giving reasons that BC is parallel to AD. We have to prove that this line is parallel to that line. We can either say AD or we can just say this whole line. So these two lines must be parallel. To prove that lines are parallel, we must use the converse of the prop theorem. So I'm going to quickly explain. If you can prove, so let's say you have a triangle like that. If you can prove that this over this gives you the same answer as this over that, then this line is parallel to that line. So any combination, of course. You can also just prove that this over the whole thing is this over the whole thing. Then this line is parallel to that line. So any combination, as long as what you do on the right, you do on the left. Okay, so let's see if we can prove something like that. So I took out triangle DRS, and remember this is a ratio. So now I'm going to write this down. So I'm going to quickly check. I'm going to write down. Let's work out what is RB over BS. So RB over BS is 5 over 3. That was given. Then I'm going to work out. So remember, I now said this over that. So what I do on the right, I must check on the left. So I'm going to check, what is this over that? So let's write it down. So I'm going to check, what's DC over CS? Now DC was 20 and CS was 12. And if I simplify this, 4 goes into 25 times and 4 goes into 12 3 times. Can you see I get the same answer? I can now conclude this line is parallel to that line. So I'm just going to write that down. BS is parallel, and I can either say the whole line or just a small part of the line. So we had to prove that it's parallel to AD. And my reason is line parallel to one side of triangle. So I'm just going to fill that in. That is parallel to that. The next question is 8.2.2, and it says, it is further given that RD is 48 units. So this whole side is 48 units. And then it says calculate, and you have to give your reasons, the value of the ratio AD is to AB. So we have to calculate AD is to AB. I'm going to start with AD. So maybe I can just work out the length of AD, and then I can work out the length of AB, and then write those two answers as a ratio. So let's start with AD. If you take out triangle RDS. If you take that triangle out, it's given that this line is parallel to that. So that's a prop theorem triangle. So if this is 5 and 3, let's add K. Then this side is also 5 and 3. Here we can add X. Can you see there? So I'm just going to write that down quickly. So I'm going to say RB over BS is RA over AD. And that is 5 over 3. My reason is prop theorem. The lines that are parallel is AB is parallel to DS. Okay, so I filled that in. So if this whole line RD is 48 units, and this part is 3x and that part is 5x, then I can say 8x is the same thing as 48 units. Do you agree? 8x is this side and the whole 48. They are equal to each other. So x is 6 units. So AD is 3x. Is 3 times 6. So AD is 18 units. There I have AD. I'm going to see if I can work out AB because the question said work out AD is to AB. I just need the length of AB. AB is this side over here. This is AB. Let's take all of this away. Can you see that AB is a palm? So this is a palm. How do I know? Because this is parallel to this and this is parallel to that. That's a palm. Both pairs of opposite sides are parallel. So A, B, C, D is a palm. Why? Both pairs of opposite sides are parallel. That means if we know the properties of a palm, this is equal to that, and this length is equal to that. So if BC is 20, then AB is also 20. AB is 20 units. Why? Because opposite sides of a palm are equal. Therefore, I can now answer the question. AD is to AB. AD was 18 and AB is 20. And if I have to simplify that, I get 9 is to 10. Let's look at the next question of this paper. Question 9.2 says DEFG is a cyclic quad. They also say that EF is parallel to DG and DH is parallel to FG. That's also indicated. And it says angle D1 is X. That's also indicated. Question, prove giving reasons why angle D1 is equal to angle D2. So why is D1 equal to D2? Let's make some notes, grade 12s. Let's say you have a cyclic quad. Let's say this is a cyclic quad. If this is 50, then this angle is 130. So how did I get 130? I know that the opposite angles of a cyclic quad, they add up to 180. So if this one is 50, then this one over here is 180 minus 50. And that's how I got 130. Okay, that's easy. But let's say this angle is X. Then what is this angle? This angle is then 180 minus X. And I can't simplify that. So that is my answer. So this angle is 180 minus X. And the reason is opposite angles of a cyclic quad. Okay, so if two things add up to 180. So if I have two things and they add up to 180. And the one is X. Then the other one is 180 minus X. Let me show you something else. Let's say you have lines that are parallel. Okay, and you have this line here, a transversal, and this angle is 50. What's the size of this angle? It's 130. Okay, so how did you work that out? You had to work out this angle, you would say 180 minus 50. That's how you would get that answer. But let's say this is x. Then what's this angle over here? It is 180 minus x. I'm going to do another example. Let's say this angle is 180 minus x. Then what is this angle? So remember, if something plus something is 180, and this is x, then this is 180 minus x. Now, if this is given, then what is the other angle? And we know they must add up to 180. The other one is x. So this is definitely x. And the reason is co-interior angles because the lines are parallel. That's just a side note. Let's look at this question. Do you see the cyclic quad DEFG that I highlighted? Now, if D1 is x, I'm going to take it out. D1 is on top here. D1 is x. Then angle F is 180 minus x because this plus this is 180. Opposite angles of a cyclic quad. So I'm going to write that down. So I'm going to say angle F is 180 minus x. Opposite angles of a cyclic quad. And then I write that in. So I go make that 180 minus x. So I'm still not by D2. Remember, we have to prove that D1 is equal to D2. So I'm going to go to angle G now. So angle G, if I take out these two parallel lines, let's look. This is parallel to that. Here's F and G. F is 180 minus x. That's F. So then G is x because this angle plus this angle is equal to 180. Co-interior angles. So I'm going to write that down. So I'm going to say angle G is x. Co-interior angles, FE is parallel to GD. So I'm going to write that information in. That's x. Now I'm going to see, can't I go from G to D2? Now let's look at our information again. This line is parallel to this line. And you see there is a transversal. So do you see the Z? So here is the Z. This line is parallel to that line. So we know that this is equal to that. Alternating angles. Isn't this D2? Therefore, angle D2 is x. Angles, DH is parallel to FG. And therefore, angle D1 is x and angle D2 is also x. The last question of this question paper is question 10. And it says in the diagram, TR is a diameter. So remember, diameter means angle in a semicircle. And PRKT is a cyclic quad. And then they say you have chords. And PK is equal to TK. That's given. The first question is 10.1.1. Prove giving reasons that SR is a diameter to the circle SPR. So you have to prove that SR is a diameter to that circle. Okay, so I'm going to make notes. So let's say you have a triangle like this. You have ABC. And the question is, prove that AB is a diameter to the circle ABC. So if you have to prove that this is the diameter, then wherever A and B goes, so let's say this is A and this is B, so wherever it goes, so they both going to C. If you can prove that this is 90, then this is a diameter. because then you have the converse of angle in a semicircle. So let's go to our question. It says prove that SR. So we have to prove that SR is a diameter to the circle SPR. So to the circle SPR. So S goes to P and R goes to P. So we have to prove that P3, this whole P, we have to prove that that's 90. So our plan is to prove that P3 is 90. Let's see if we can do that. So I'm going to start with the information. The information said that TR is a diameter. So that's a diameter. It cuts the circle in half. So my theorem says if I have a diameter, wherever the diameter goes to the circumference, that angle is 90. Angle in a semicircle. So I'm going to look for that now, eh? So can you see that R and T can go to K? It's on the circumference. That means this whole K1, this whole angle K is 90. So this whole angle K1 and 2 is 90. Let's write that down. So I'm going to say angle is KT. That's that whole angle K. Or you can say K1 plus K2. But this is 90. Either way. And the reason is angle in a semicircle. Okay, so there we have a 90. Remember, our plan is to get P3 to be 90. P3 is by a cyclic quad. So look here. If this is a cyclic quad, our theorem says that this angle is then equal to that exterior angle of cyclic quad. So I'm going to look for that now in the diagram. The information said PR KT is a cyclic quad. So can you see if I extend this line like that, I have the exterior angle of a cyclic quad. So that means this P3 is also 90. And there I proved my plan. My plan was to prove that P3 is 90. So now I just say P3 is then also 90 because of exterior angle of cyclic quad. Therefore, my plan worked. Therefore, SR is a diameter. So therefore, SR is a diameter. Converse angle in a semicircle. So is okay, next question, 10.1.2. It says prove that angle S is equal to angle P2. This one is a tough one, but I think we can do it. I just have to show you a few things. So let's work it out. 90 minus x plus 90 plus x. What is the answer to this? So this 90 and that 90, they are like terms. It's 180. And negative x and plus x will cancel. So the answer is 180 and angles on a straight line is equal to 180. So just make sure you understand that before we answer this question now. So now I'm going to answer this question. So remember we have to prove that angle S is equal to angle P2. So I'm going to work in triangle PTK because the information that was given was that PK is equal to TK. So I have this triangle where this is equal to that. So that means this is equal to that. Angles opposite equal sides. So I'm going to let angle P1, I'm going to let this be my X. So let's start. I'm going to write that. Let angle P1 be X. Now if angle P1 is X, so this is X, it means this angle is also X. Angles opposite equal sides. So this whole T1 and 2. So therefore, T1 plus T2, that whole angle is also X. Angles opposite equal sides. Angles opposite equal sides. So remember, I have to prove that S is P2. So now, I want to get to P2. Grade 12s, do you see? This is a straight line. So grade 12, do you see angle P here? I'm just going to take it out so you can see. There you have a line and there you have a line. This is 90. We've proven that, eh? This is X. What is the value of this angle over there? That's angle P2. So can you see it's three angles on a line that will give me angles on a straight line. There's a 90, there's an X. So this is 90 minus X. Angles on a straight line. If you don't feel confident, you can actually work it out. You can say angle P2 is 180 minus 90 minus X. Angles on a straight line. So therefore angle P2 is 180 minus 90 is 180 minus 90 is 90, and X doesn't have a like term. So therefore P2 is 90 minus X. So there you've worked out P2. So we have P2. We just need to work out angle S. I'm going to work in the big triangle. Angle STK. Remember we proved that this whole K is 90. So let's take it out. I'm going to take it out so you can see. This is 90. This is X. So what is this angle over here? It's 90 minus X because they go together. If you don't feel confident, I'm going to write angle S plus angle T plus angle K must give me 180. Angles in a triangle. I don't know what S is, but T is X and K, the whole K is 90, and that must be 180. So now, angle S is 180 minus 90 minus X. So I'm bringing this and this over. So angle S is, this is 90 minus X. And P2 is 90 minus X. S is 90 minus X. Therefore, angle P2 is the same as angle S. Okay, let's look at the next question. 10.1.3. Prove that triangle SPK is similar to triangle PRK. Can you see the one triangle is inside the other? So because the one is inside the other, they have a common angle. So in triangle SPK and triangle PRK, K is equal to K. That's common. So we just need one more angle, eh? Then they are similar. So we did prove in the previous question that angle S, you see the red dot, angle S in the orange triangle is the same size as angle P2, and this was proven. So that means in the orange triangle, I've used K, I've used S, so now that means angle P is equal to angle, I've used K, so there, this is the K, and I've used P2, so that's P. So that means it's equal to angle R. This is third angle. So therefore, triangle SPK is similar to triangle PRK. Reason, you must have your reason, angle, angle, angle. So let's look at the last question. Question 10.2 says, it is further given that SR is the same length as RK. We have to prove this. ST is equal to root 6 times RK. That's our last question. Let's see if we can do that. Okay, when you look at this question, there's a square root. So to get to a square root, you must have something squared. So I'm going to use the similar triangles and see if I can just start from there. So when I look at my similar triangles, we know the first two over the first two. So let's go. SP over PR, that's the first two over the first two, is the last two over the last two. So that's the last two. And first and last, first and last. So this is first and last, first and last. The triangles are similar. Now I must use any two of these fractions. So which two fractions am I going to use? I am going to use, so I am definitely going to use this one. I'm going to use these two because when I cross multiply, I have something squared. So I'm going to go, this times this is then pk squared. And this times this is sk times rk. And then I'm stuck. So I'm stuck. There's nothing I can do with that. So now I'm going to go back to my diagram and I'm going to just check again. Isn't there anything else squared I can use? Now, do you see the right angle triangles? If you have a right angle triangle, can't we use Pythagoras to work out a missing side? Okay, so you see that right angle triangle there. And that is, Pythagoras is definitely something squared. So I'm going to use that. So now I must just decide what am I working out. So because it says I have to prove that ST is equal to something, let me start there. Maybe I can say ST squared. So if you take out the triangle, this is S and this is T and this is K and this is a right angle triangle. So this is the hypotenuse. So this squared is this squared plus that squared. So I'm going to write that down. ST squared is SK squared plus TK squared. And that is Pythag. In the diagram, do you see that TK, there, this line, this TK, it was given that it's the same length as PK. So let's write, but TK is equal to PK. So can't I now go and replace TK with PK? Which is, so I'm going to replace my TK with PK. So I'm going to rewrite this ST squared again. So I'm going to rewrite ST squared is equal to SK squared, but instead of writing TK, I'm writing PK squared. So there, I just replaced TK with PK. Okay, now remember we still have this over here. PK squared is actually this over here. Can't I go fill this in here? So I'm going to do that. So I'm going to say ST squared is equal to SK squared plus, but PK squared is SK times RK. So now I have to see, I want to prove the following. I want to prove that ST is root 6 of RK. Okay, I need to get here. I already have ST, tick. So I already have an ST and I already have an RK. But here I have an SK and there I have an SK. So I need to figure out how can I get rid of SK. Let's go to the information. Our information said that SR is equal to RK. So I'm going to write this down. SR is equal to RK. So this whole SK, do you see that whole line? This whole SK, this to this, that line, consists of SR plus RK. Okay? So I'm just saying it's this plus that. So SK is equal to, now can't I now replace SR with RK? Because SR is then the same as RK. So because they are the same, I'm going to write SK is RK plus RK. So SK is actually 2RK. So I'm going to rewrite that information down here for you so you can see. We said SK is 2RK. Okay, so wherever there's an SK, I'm going to write 2RK. So here's an SK, so I'm going to write 2RK, but everything is still squared. Plus, here's another SK, so I'm going to write 2RK. And then there's the RK that was there. Now I'm just going to multiply this out. So this is ST squared. 2 squared is 4, and RK squared is RK squared. Plus 2RK squared. RK times RK is RK squared. And they are like terms. So ST squared is 4 plus 2. That's 6. RK squared. But the question said you have to show that ST is equal to something. So I'm going to root both sides. So root and root. This just becomes ST. Root of 6 is root 6. And the square root of RK squared is RK. And there you proved it. Okay, that one was a little bit difficult. But if you go through it slowly again, I think you'll be able to do it.